So today we are getting to learn how to divide by two-digit divisors. Okay, it's the poster that's been hanging up on the wall for weeks now. It has our steps still the same as dividing by single-digit divisors. You divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. It doesn't change, okay? Our steps are still the same. We've been practicing all week in our bell ringer. We've been exposed to two-digit divisors. Now we're just learning some strategies on how to figure out how many times that big divisor can go into my dividend, okay? So let's look at the very first one. I'm going to actually rewrite these down below so I have some more space because they're really crowded and that's not near enough room to work all that out. So we're going to rewrite number 1 down below. I have 18 as my divisor and 612 as my dividend. Okay, we're starting with 3-digit dividends divided by 2-digit divisors just because they're a little bit smaller numbers, but we'll work our way up to 4-digit dividends, so we'll be doing bigger numbers as we go. All right, so same concept as when you're dividing by a single digit. You're going to divide first. So I'm going to ask myself, how many groups of 18 can go into 6? 0. So I put a little 0 up there. You can put a little X, placeholder, whatever you want to do. Okay, I can do that next step where I do 18 times 0, which is 0, subtract, bring down, or I can just skip on over. And now I'm going to look at this as, let me draw my little box here. Now I'm going to move this over and I'm looking at 61. So I'm dividing 18 now into 61. Okay, well, what is 18 kind of close to? 20. It's real easy, right? 20s are easy to work with. About how many 20s can divide into 61? 3. Now, that doesn't mean 18 can go in 3 times. I want to double check myself. Okay, I have to know anyway the exact amount because if it does go in 3 times, I need to know what to subtract. So off to the side, I'm going to work out 18 times 3 to see what it gives me. And it's 54. So will it work? Yes, it will. Is it too much or is it too little? Like, can it go in again?
No.
No, because if I did another 18, it'd be way too much, right? So I'm going to put a 3, and I already know that 18 times 3 is 54, so now I'll subtract that part. Okay, when I subtract, it does require a little borrowing and regrouping, so I am left with 7, and then I bring down. Okay, that's my first round. Now I go round 2. Round 2, I start all over again. I start dividing again. Okay, now I'm looking at 18 into 72 because I have brought that 2 down. Again, 18's pretty close to 20. So about how many 20s could go into 72? It's close to 80, so we could try 18 times 4. We already know 18 times 3 is 54, right? So we could try 18 times 4 and see if it gives us a number that works. If it's too much, then I will just end up with the remainder, and that's okay. Okay, so let's try 18 times 4. Again, if I'm writing, guys, you're writing, you should be copying everything that I do. Okay, here we go. 8 times 4 is 32. Carry that 3.
72.
And then 4 times 1 is 4 plus 3 is exactly 72. So I'm going to put that 4 up here, subtract 72. I have 0 left over. So my answer for number 1 is 34. Not too bad. We're going to do a little bit more practice. So let's look at number 3. Okay, number 3. All right, on number 3, oops, didn't mean to do that. Move my little box over here. Can 30 go into 5?
No.
Nope, so put a 0 above that first digit. Okay, can it go into 58?
Yes.
Okay, I've got a really nice divisor because it's a multiple of 10, so it's really easy for me to work with. I know 30 can go into 58 only one time because 30 times 2 would be too much. So I'm going to subtract 30, and I'm left with 28. But then what do I need to do? I got to bring that other number down. Okay, now 30 and 280. That's a lot. But they both end in zeros, right? So what if I just ignored my zeros for a minute and thought about 3 and 28? How many 3s go into 28?
9.
9. What is 9 times 3?
27.
27. So then thinking of 30s, if I just put those zeros back on, how many 30s could go into 28? 9.
90.
But it would be 270, right? So if I did 30 times 9, y'all see how this works. 30 times 9, that's a 0 at the end, and then it's just 27. So I know that 30 goes into 280 9 times, which is 270. So I would have a remainder this time. What's my remainder going to be?
10.
It's going to be remainder 10 because when I subtract this, I have 10 left over. When I write my remainder, you just put that little R. I don't care if it's capitalized, lowercase. Just show me that you know there's a remainder 10. So 19, remainder 10 on that one. Okay, how are we so far? The first two. Okay, let's do number 6 because it's a little bigger. I'm going to rewrite this one down at the bottom since I kind of went into it a second ago on number 3. So I'm going to move this one. I'm going to write it right down here. 77 is my divisor. 8, 5, 4, 7 is my dividend. Okay. I guess I'm going to have to... I'm doing this down at the bottom. So you can do how I am. Just draw a little arrow for number 6 and move it down towards the bottom. Yes?
Can we have a 3-digit number remainder?
No, that's a great question. Okay, he asked, can you have a 3-digit number remainder? If my divisor is only 2 digits, my remainder can never be greater than 2 digits. My remainder should never actually be bigger than what my divisor is, okay? My remainder should always be less because if it's bigger, that means that I messed up here in my quotient and I actually could have divided this probably one more time. Okay, so your remainder should always be less than your divisor. If you had a 3-digit divisor, it could be a 3-digit. It would still have to be less than your divisor, though. Does that make sense?
Yeah.
Okay. So if you're dividing by 2 digits, you will never, ever have a 3-digit remainder. Ever. Okay, back to number 6. So we're working this one out together. I'm going to go ahead and put my box up here. Can 77 go into 8? No. Can it go into 85? Yes, it can. Only once. 77 times 1 is 77. When I subtract, it does require some borrowing and regrouping. If I'm writing, you should also be writing. So this is going to be 8 left over. And then what am I bringing down?
The 4. I'm not getting that. Yeah, 4.
I'm bringing the 4 down. Okay, I already know because we just put 77 into 85 once. I know also 77 can only go into 84 once. And 77 times 1, again, is 77. And I have 7 left over this time because if I borrow, that becomes 14. And then I have one more digit to bring down. And 77 divides into 77 exactly 1 time. So my answer up there, this is going to be 111. Okay. Let's try number 9. It's another 4-digit by 2-digit. Just so you have one more example in your book. Just answers help you 0. You have to show your work. If I'm writing anything, you should be copying down what I'm writing. Okay, down at the bottom, I am going to rewrite this. 6,942 divided by 54. Okay. Oh, that's interesting.
That is weird.
That is really weird. Let me see. I think it's...
Did you write the 9
942 on top of the y.
I'm just gonna, I'll make a new one. Okay, we'll just do that. Okay, so 54 cannot go into 6, but it can go into 69 how many times? If I have 69 buttons, I can only make one group of 54. I can only pull out one set of 54, right? Okay, so 1. I'm going to subtract 54, and that's 15 left over. Is it okay to have a 2-digit remainder right here? Yes, because why? Because it's less than the divisor. Okay, now I'm going to move over this box, and I'm going to do what with that 4? Bring it down. So now I have 154. Okay, 54 and 154 are pretty close to 50 and 150. So those are a little bit easier. Y'all, I use estimation a lot, and I use what we call compatible numbers, numbers that work well together, a lot when I'm dividing like this, because 54 and 154, those are hard numbers, okay? So I want to just get a place where I can start. Okay, I know that 3 50s make up 150. So maybe 3 54s could go into 154, or do we think maybe that's too much? Maybe too much? Yeah. So, okay, so then we're going to try 54 times 2, and we're going to see what that gives us. I have her next.
Okay, so she's probably in Spain.
Yes. Yeah. I had to think about that for a second. Okay. So, did I mess up? 54 times 2? Oh, you're way ahead of me. Okay, hold up. All right. Look at what I'm left with here. It's really close to my divisor, right? Okay, but it's not bigger than my divisor. The problem that I would have, I want you to know and I want you to understand, when you subtract, this number should never be what my divisor is or greater. If it is, and I've messed up here somewhere, okay? So 54 times 2 does work. It is 102. I'm only left with 52 left over. It worked out great. So I have one more digit that I need to bring down, and that's a 2. So 52 now turns into 522. Again, estimation is so helpful, because if I were to round this to 50 and this to 500, what do I know about those two numbers? 10. Can I put 2 digits in my quotient?
Yes.
No, never ever. Only 0 through 9, okay? Only 0 through 9 can go in my quotient. What's a quotient again? The answer to a division problem. Okay, have you ever written a 2-digit number up here in your quotient? It's got to be 9 or less. So that means I could try 54 times 9, because that's the biggest number that I could put up there. That's 36. 45 plus 3 is 48. So that does work. And then I subtract 486. Does require some borrowing and regrouping. Twice, actually. So it's 129. And what's my remainder? 36. Okay. Bigger numbers, but still doable. Do you think rushing through this is going to help? No. You need to go slow, take your time. How important is it, do you think, keeping everything in line is? Very important, because if you forget to put like a placeholder up here, like a 0 here, and you put the 1 over instead, your numbers are all mixed up. Okay, so don't forget those 0 the heroes. Don't forget your little placeholder X, whatever you choose to use.